So today's lesson 11.3, Binomial Theorem. What we're talking about, break this down a little bit. Binomial means two terms, okay? A polynomial with two terms. So x plus y right here is a binomial. 2x minus 3y is a binomial, okay? Two terms only. The binomial theorem is basically a shortcut to expanding binomials of n degree. Doesn't matter what degree it is. Okay, so for example, if you have x plus y to the power of 5, obviously there's a long way to do that, right? You can do x plus y times x plus y. That's squared. So you do that and you simplify those terms. Then you take that and you multiply it again times x plus y, and that would be x plus y to the power of 3. Then you take that big answer and multiply it again, and then you multiply it again and one more time. So that's the long way, which nobody really wants to do. But the neat thing about this section is they're identifying to you a shortcut. Now this has been a long time that this little, it's called Pascal's triangle. This is different. This is someone else's triangle, but Blaise Pascal is it's named after. And we just read a little bit here. In 1653, Pascal, a French mathematician, described a triangular array of numbers corresponding to the number of ways to choose r elements from a set of n objects. So when we talk about those terms, that's combinations, okay? You choose a certain number of elements from a total number of objects. So we'll talk a little bit more about that in a bit. Some interesting number patterns occur in Pascal's triangle. So we're going to flesh this out a little bit. I'm going to show you kind of how we came upon it and how you make Pascal's triangle. And then I'm going to show you some connections to combinations and connections to the expansion of a binomial. Okay, so that's what the lesson is sort of on today. And this is the kind of the beginning of Pascal's triangle. So as far as notes go, where are we? Nope, not that section. Oh, Calc 30. Well, what happened here? There. Well, I don't know why that didn't show up. Okay. So, Pascal's triangle. Okay. It's a triangular array of numbers, and it always starts with a 1 at the top. And the second row, this is first row, the second row has two 1s. Okay? So we have sort of the simplest little triangle, right? A base of two numbers and a top. Now, the third row here, there's some patterns. Now, the row always starts with a 1. Each row always starts with a 1. But as you move to the right, what you have to take a close notice of are the two numbers on either side of this number placement. So here's where the second number would go, right? And what you do is you look above it and you say there's a 1 here and a 1 here. So you add them and you write the number here. So there's actually a 2 goes here. And then this is the end of the row, and the end of the row always has a 1. So that's the third row of Pascal's triangle. This pattern is repeated, okay, as we move through. You start with a 1. The next spot would be this spot that's right underneath sort of these two numbers, and the sum is 3. Okay, does everyone see that? Again, you look at the two numbers that are above and to the right and left of the number position. And maybe these boxes will help. Maybe I'll put some boxes here for the terms. So we have 1s on the end, and we have these boxes. So what number goes in here? Another 3. Yeah. Very good. Okay, so we'll do a 1 here, and how many boxes do we have? Well, we have 1 here, 1 here, 1 here, and then a 1 at the end. And so you look again at this box here, and you look at 1 and 3, and of course a 4 goes there. This box here, you look up to the left and to the right, and this is 6. And then here is a 4. Okay? Is everyone seeing this pattern so far? Okay, pretty simple, right? Really simple. And this could go on forever. There's no end to this. There's no end at all. This is going to be 1, and this is going to be 5, 10, 10, 5, 1. Let's do one more row here. 1, and then 5 and 1, right? You just add them up. Okay, and that's how Pascal's triangle is created. And again, you could keep going on forever and ever and ever. There's a few things that you should note about Pascal's triangle. Okay, row 1 has one term. Row 2 has two terms, etc. Okay? So whatever row it is, that's the number of terms that it has. Something else you should notice, well, what about you guys? Is there anything else you notice about this triangle? Okay, that's worth noting that you have 1, 2, 3, 4, 5, 6, kind of like in this pattern like that, and also in this one like that. Okay, that's good observation. Yeah. Is there any other patterns like that that you can see? Like, does it? What about subsequent sort of diagonal rows? Is there any commonality here? Like, what's happening here with this pattern? Well, we're adding 2, adding 3, adding 4, adding 5, I suppose. 3, 6, 10. Yeah, kind of starts to lose a bit there, but that's a good observation. Okay, anybody else? You are going to want to notice that the triangle is symmetrical. Okay, now obviously we have, there's a middle here where there's one on the left, one on the right. This number here, okay, represents the middle, so it's the same over here and over here. If you move down here, this is the middle number, and you see it's 1, 6, 15, and then the middle number, 15, 6, 1. So it's sort of a reflection from the middle. Even the ones that have an even number of numbers, you see if this is the middle, it's a reflection, see? It's sort of got this symmetry, okay? That's important. That's going to help you when you're expanding. Okay, now I want to talk to you a little bit about the combinations notion, okay? So combinations, when we're calculating the number of combinations that we have, we set it up like this, okay? So we set, I think from the wording from the text, we have an R here, then we have a C, and then we have an N. The R and the N are subscripts, okay? So for this particular lesson, we haven't talked a lot about combinations. I'm going to show you how they work here, just a little bit of a quick lesson on them. So how many do we have in this class? 24. So let's say, actually, I'm just going to back this up here. The book talks about R and N. Your calculators, however, I think they all are NCR. So let's take that. Is that what the book says there too? Okay, all right. So NCR, we're going to use NCR. Now N is the total number of items, okay, or objects or whatever it is. R is, what did it say there? The selected number of items, okay. So the elements really, the elements in the question. So it's a portion of the total. And let's say we use an example off the at the beginning of the class where we had, I talked about those 3 boys, right? So how many combinations of 3 people in general can we have out of this classroom? So that means how many groups of 3, different groups of 3 can I make out of all you guys, right? So if we take the first 3 here, that's 1. If we take the second, kind of starting with you, the second, that's another 1. And then that's another group, that's another group. So we could kind of do this, but you 2 could go with someone over here as well. And then the next one over there, and so on. So we have a lot. But how we calculate that is we would take the total number, so we have 24 students in this class, and we would, C stands for combination, but the wording you could use is choose. So we want to choose 3 at a time. Okay? This is going to be a pretty big number, and on your calculator, if you have a scientific calculator like you should have the NCR button. If you're using a graphing calculator like mine, it's going to be just maybe a little bit different. You're going to have to go to, I think it's math here, and probability. Yeah, you see how you have NCR? So this is what's going to have to happen. You have to put 24, and then you guys should have a second, like a second function. and then you should have NCR over one of yours. But I'm going to go here, number 3, and I'm going to choose 3. So 2024, do you guys get that on your calculators? Okay. You all should be sort of trying that on your calculator to make sure you get it. 24, choose 3. That's a lot. Did anybody get that? No? You get something different? You got something different? Do you have a scientific calculator there? It's on there. Okay, so 2024, that's how many different combinations. If we had this whole class to get groups of 3 people, we could have 2024 distinct groups of 3 people. That's a lot. The order in which you stand in a line doesn't matter. It's just the people in the group. So that's a lot. Now, I want you to do these ones here. So why don't you do 5, choose 0. Okay, I'm going to get you to do these right here. 5, choose 0. I'm going to get you to write the answer down sort of underneath it. Then I'm going to get you 5, choose 1. Right there. 5, choose 2. And we're going to continue that all the way up to, well, I'll write them out here, I guess, but all the way up to 5, choose 5. Okay. What do you notice about the answers here? 5, choose 0 is 1. 5, choose 1 is 5. 5, choose 2 is 10. 5, choose 3 is 10. 5, choose 4 is 5. And 5, choose 5 is 1. What do you notice about this set of numbers right here? Sorry? Okay, it's a reflection. Yeah, it's symmetrical, just like we talked about in Pascal's triangle. Okay, if we go back to sort of our creation of Pascal's triangle, what do you notice? Okay, yeah, you should know that it is row 5. Right here. Oops, lost it. Come back. So this row right here, this is row 5, and it corresponds to the combinations when you have 5. Start with 5 items. Choose 0. Choose 1, choose 2, choose 3, choose 4, and choose 5. Okay? So what I want you to do is I want you to pick one other row between here and see if, okay, so actually let me just help you. This half of the room, you guys do this row. This half of the room, you guys do this row. I want you to do the same thing, double check, just to make sure that this works for your combination. Okay, so this is row 4, so do 4, choose 0. Do 4, choose 1, and so on. So this is actually row 6. Thank you for noticing that. The row numbers, as I just mentioned, will not be as important as what we're going to talk about next. So I don't want to quite get there yet. But anyways, focus on this and this row right here. We'll just confirm that those do work for those 2 rows. Oops. Okay, so if we take a look at this in your notebook, in your textbook here, this is sort of how it comes about. Now I want to take a few minutes on this. All right. What you guys did was down here. Okay. So you guys did this one right here. This is actually row 1, 2, 3, 4, 5. Okay. And it's row 5, but you start with 4, and I'll tell you why in a second. But you did this, this, and this, and this, and this, and they did actually line up with these numbers. Okay? So you don't have to create Pascal's triangle for every binomial expansion. If you have Pascal's triangle made up to, the 11th or 12th, 15th row, whatever, if you have that in your book, that's great. You don't need to do that in working out these questions. What you can do is you can realize that there is a bit of a shortcut here to finding out the row of numbers. Okay? So the rows are on the side here. We are basically going to forget about that for now. The rows are not really that important because, as already happened with me, I don't do the rows, but it's in the book. So yeah, I kind of got that wrote down the wrong thing there. But this is what's important. If you